All right, this is section 16.3, the quadratic formula. We're going to start with a little review. For this problem number 1, solve by completing the square. Go ahead and hit pause and see if you remember how to do this. All right, so the first thing we want to do is have that leading coefficient with that x squared. We want that to be a 1. So we're going to go through and divide every single piece by 2. When we do that, we get x squared minus 6x plus 1 equals 0. Now we want to complete the square, so let's move over that 1. So we're going to have an x squared minus 6x. We're going to put something here equals a negative 1 with another blank to fill in. While we're here, let's go ahead and set up our next line. So remember that piece squared equals something here. We'll go ahead and fill in those blanks. If you didn't get this far yet, go and hit pause and try to finish it off. Okay, so remember what goes in those parentheses with the x and the squared is half of your b. So our b is negative 6. Half of that would be negative 3. And what goes up here on the next line above, that c is whatever we said half of b was, but we square it. So negative 3 squared is a positive 9. Whatever we add to one side, we add to the other. So now we have the quantity x minus 3 squared equals a negative 1 plus 9, which is 8. Now we can go ahead and take the square root of both sides, leaving us with an x minus 3 equals plus or minus the square root of 8. We're solving for x, so we add 3 to both sides, so we have x equals 3 plus or minus the square root of 8, but remember we can reduce the square root of 8 down to 2 times the square root of 2. And that is our final answer. Now we're going to do this just with the general standard form with variables, just to see what happens. You won't ever be asked to do this. If you don't even want to write down this part, you don't have to. You can just follow along. But we're going to go through and do each of the same steps. The first thing we did in our last one was we divided everything by that leading coefficient to make sure it was 1. So let's divide everything by a. So now I have an x squared plus a b over ax plus c over a equals 0. Okay, the next thing that we did was we removed that constant piece. We put it onto the other side so that then we could complete the square. So we'll just get that set up just like this. Now remember what goes there in the parentheses, that was half of our b, right? So after the side, I'm going to write b, which is b over a. So half of that middle term here. So I'm going to go times 1/2 would give me a b over 2a. So that is half of b. So I'm going to write plus b over 2a. And again, what goes on the line up above it in that blank is whatever we said goes there, but it's squared. So let's go ahead and square b over 2a. We get b squared over 4a squared. So that will go here in this blank. And since I added it to one side, I have to also add it to the other. My next step would be to combine these two fractions here, but they don't have a common denominator yet, so let's go work on that. If this first one just has an a and the second one has 4a squared, I need to multiply this first one by 4a over 4a. So I'm going to have a negative 4ac over 4a squared plus a b squared over 4a squared. So now I have common denominators, so I can put them all over 4a squared. Okay, one last thing I'm going to do is when I actually go write this down over here in my original problem, let me go ahead and erase this blank just so I have more room. I'm going to go ahead and write it with the b squared first, just so I have a b squared minus 4ac all over 4a squared. Now remember when we got to this step before, we took the square root of both sides. So I would end up with an x plus b over 2a equals plus or minus the square root of everything I have over there on the right. I'm going to combine a couple of steps and go ahead and put a square root of b squared minus 4ac on top, because I'm recognizing right away that I could take the square root of the top and the bottom separately, and on the bottom I see 4a squared, which the square root of that would just be 2a. Okay, I'm going to bump this plus or minus down a tad bit. So now I want to get that x by itself. So I have x equals a negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. They actually have a common denominator. So let's rewrite it as negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now if you've just been following along, I would definitely write this piece down. Hopefully this vaguely looks familiar to you. This is actually the quadratic formula. So far, we've started off the quarter by factoring to find those roots that we had. And then just recently we've been working on completing the square. And then we took the process for completing the square and we made it general with A's, B's, and C's. And when we completed the square for the general standard form, that ends up being the quadratic formula. So what this means now is we can just take each of those numbers, A, B, and C, when we're given a quadratic, and instead of completing the square or factoring, we can go ahead and plug in those numbers for our variables using the quadratic formula. Go ahead and try these first three. Let's see how you do. For number 3, my hint would be don't forget that it has to be set equal to 0. So I'd subtract a 1/3 from both sides. And those fractions are going to get kind of messy. So I would go ahead and multiply by your least common multiple, which would be 12. That will help wipe out your fractions. Okay, so go ahead and hit pause and try those first 3. All right, so in our quadratic formula, we have negative b. Well, b here is already negative. So negative 5 would be a positive 5. Plus or minus the square root of b squared, which we said b was negative 5. So it's going to be a 25 minus 4 times a is just 1 times c is 3 all over 2 times a, which we said a was 1. If you didn't get quite that far, go ahead and hit pause again and try to finish this one off. All right, so now I have 5 plus or minus the square root of 25 minus 4 times 3. So it would be 12. So 25 minus 12 would be the square root of 13, all over 2. We can't reduce that radical, so that's our final answer. Okay, for number 2, we have negative b, which again is negative. So a negative 2 would be a positive 2, plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a times c, all over 2 times a. When we simplify, we get 2 plus or minus. If you do 4 minus 4 times 7 is 28. You would get the square root of negative 24 over 14. So remember, with that radical having that negative, the square root of negative 1 would be an I. So we can go ahead and pull an I out front. Let's go ahead and do that now. And then the square root of 24, we can go ahead and reduce that. Maybe I'll show a little bit of work here. If you don't need to do this, don't worry about it. But I'm going to go ahead and put square root of 4 times square root of 6, just so hopefully I don't lose anybody. Okay, so I have 2 plus or minus the square root of 4 is 2. So I have 2i times the square root of 6 all over 14. And then I can reduce, because this 2 over 14 is really 1 over 7. So really I have a 1 plus or minus I times the square root of 6 all over 7. Or if you would like to write it broken apart, that's totally fine too. You would have a 1/7 plus or minus square root of 6 over 7i. Okay, for this last one, remember I said we'd want to subtract the 1/3 and multiply everything by 12. All right, so 12 over 4 is 3. So 3 times 3 is a 9x squared, minus a 12 over 2 is a 6x. 12 over 3 is a 4. So I have 9x squared minus 6x minus 4 equals 0. I can now go use the quadratic formula, which is negative b. So it's a negative 6 is a positive 6, plus or minus the square root of b squared, so it's 36, minus 4 times a times c, all over 2a. So 2 times 9. Now I have 6 plus or minus the square root of, if you do 36, and then you have this minus 4 times 9 times a negative 4, that's 36 plus 144, or 180. So I have 6 plus or minus the square root of 180 all over 18. I can reduce the square root of 180 to 6 times the square root of 5 all over 18. And again, 6 over 18, I have twice on here, so I can go ahead and reduce that to a 1 plus or minus the square root of 5 over 3. Some people were kind of confused by this reduction. You can think of it like this, factoring out a 6. So 6, you would have a 1 plus or minus the square root of 5 all over 18, and that might be a little bit more clear to see that the 6 over 18 reduces down to 1 over 3, which is why we have that answer of 1 plus or minus the square root of 5 all over 3. Or if you'd like to break it apart, you would have 1/3 plus or minus the square root of 5 over 3. These next two are a little bit more challenging. For number 4, you'll want to go ahead and FOIL it out first, set it equal to 0. And for number 5, notice that that exponent is a 3, okay, that x cubed. It's the quadratic formula, meaning it needs to actually be a quadratic, which has the leading coefficient of x squared. So go ahead and factor out a 2x before you try to use the quadratic formula. Okay, go ahead and give it a try. Come back when you're ready. Okay, so I've multiplied it out, subtracted that 4x, combined like terms. Now I'm ready to use the quadratic formula. So I have a negative b, which b is 1, right? Because there's a little hidden 1 here. So I have negative b is 1, plus or minus the square root of b squared, 1 squared is just 1, minus 4 times a times c all over 2 times a. All right, if you didn't get that far yet, go ahead and hit pause and try it again. Otherwise, let's continue. So I have negative 1 plus or minus the square root. So I have this 1, and then I have a minus 4 times 3 would be a negative 12 times negative 2 would be a positive 24. So 1 plus that 24 would give me 25. All over 2 times 3 is 6. Now I have negative 1 plus or minus the square root of 25 is 5 over 6. Now that I don't have radicals, I can actually go ahead and work this one out. So what this is saying here, let's go and write both times. We'll do negative 1 plus 5 over 6 is one way. Negative 1 minus 5 over 6 is the other answer, okay? So negative 1 plus 5 is a 4 over 6, which equals 2/3. Okay, our second solution would be negative 1 minus 5 is a negative 6 over 6, which equals negative 1. So all of these so far have had 2 solutions. It's just that with the radical, it gets kind of messy to simplify. We could have found the decimal and done that to see the actual 2 solutions, but it's more precise to leave it as the radical because that's the exact decimal. So we just follow through with this method here if they are whole numbers that make it nice to go ahead and reduce. Okay, let's go and try number 5. Remember I said factor out that 2x. So hopefully you gave that a try and got 2x times the quantity x squared minus 5x plus 3 equals 0. So remember, this means that 2x equals 0. So this one actually has 3 solutions. Here's the first one, is x equals 0. Now let's go and take this piece in here in the parentheses, and that's how we're going to use the quadratic formula. So negative b, so b is negative 5. So a negative 5 would be 5, plus or minus the square root of b squared is 25, minus 4 times a now is 1, c is 3, all over 2 times a. We get 5 plus or minus the square root. If you do 25 minus that 4 times 3, you get the square root of 13, all over 2. And so again, because it's that plus or minus, that's 2 solutions. So these 2 solutions plus our x equals 0, this one actually has 3 solutions. All right, go ahead and turn the page. We just have one more page to go. And it talks about this discriminant. The discriminant is just a fancy word for the stuff that we were talking about underneath the radical, right? Let me go back up to the quadratic formula. See there, the quadratic formula? This b squared minus 4ac, that's just the stuff under the radical. So that's called the discriminant. And the discriminant can tell you how many solutions it has. So if it's greater than 0, it has 2 real solutions. If it's exactly 0, it has exactly 1 real solution. If it's less than 0, it has 2 non-real solutions. Now, what does non-real mean? We actually saw this, where it ended up being less than 0. That means that we had a negative in our radical. Let me scroll up and find it. Oh, there it is. See, remember here, we had a negative here underneath of our radical. So we had a discriminant less than 0, which meant that our solutions were non-real. That's why they have that I, the imaginary number I, okay? So that's your 2 non-real. So we could take just the discriminant and figure out how many solutions we would expect to have. So we don't have to do the entire quadratic formula. So in this first one, we have 3x squared plus 11x minus 7 equals 0. Well, let's go and see what our discriminant is, and then find out how many solutions we think it has. So our discriminant is b squared minus 4ac. So b is 11. So we have 11 squared minus 4 times a times c. Okay, 11 squared is 121. Negative 4 times 3 times negative 7, I got a plus 84. 121 plus 84, I got 205. So, since 205 is greater than 0, there are 2 real solutions. Go ahead and try 2 and 3. Come back when you're ready. All right, so b squared, so we have a 6. So b squared, so 6 squared minus 4 times a is 1 times c is 9. I'm getting 36 minus 4 times 9 is 36. I got 0. This means I have exactly 1 real solution. Remember that b term is whatever is attached to the middle term, just that x. So in this case, our b is 0. So right now I have b squared, so 0 squared, minus 4 times a is 1 times c is 1. 0 squared is 0, minus 4 times 1 is 4. 0 minus 4 is negative 4. So since negative 4 is less than 0, there are 2 non-real solutions. Which again, just means it's going to have that I in our solution. Okay, just 2 more problems to go here. Determine the values for c such that x squared plus 8x plus c equals 0 will have 1 real solution. Okay, so it wants you to figure out what should c be so that it has exactly 1 real solution. Well, remember, that's when the discriminant equals 0. So the discriminant is b squared minus 4ac equals 0. Okay, so using our values for b, a, and c, which you're just going to plug in a c, try to solve that and see what should that variable c be, okay? What should that be for us? Okay, so b is 8, so I have 8 squared minus 4 times a is 1. C we don't know, so I'm just going to put c. We want that set equal to 0, so there's exactly 1 real solution. 8 squared is 64. Minus 4 times 1 times c is 4c equals 0. I'll go ahead and subtract a 64 from both sides. And then solve for c. So negative 64 divided by negative 4, I get c equals 16. This next one, determine the values for, this is a little typo, I'm sorry, this c should be a. Determine the values for a such that ax squared minus 8x plus 4 equals 0. We'll have 2 non-real solutions. So remember, non-real solutions is when your discriminant is less than 0. Okay, go ahead and give that a try. Come back when you're ready. All right, so b squared, so negative 8 squared is 64 minus 4 times a times c is less than 0. So 64, now I have a minus 4 times a times 4 is a minus 16a is less than 0. I'm going to go ahead and I'm going to move over the 16a. I'll do it both ways, just in case if you're curious, just so you can see it's the same. So now if I divide both sides by 16, I get 4 is less than a. It always seems weird to me to have a on the right, so I always rewrite it. So a, so it was open, so now it's a is greater than 4. Now the other option here would have been to move over the 64, which is totally fine. It's just that when you do this and you go to divide by a negative, when you have the inequalities, anytime you multiply or divide by a negative, you have to reverse that inequality sign. So as long as you remember to do that, it's totally fine. So I get A is greater than, whoops, I made a little mistake here. When I moved over my 64, that should have been a negative 64. Because negative 64 divided by that negative 16, now I'll have A is greater than 4. So either way, same answer. All right, and that wraps up 16.3. I hope you have a great day. See ya.